So hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Welcome. Tonight we really dive into System 1 and System 2, Thinking in LLMs. Really we'll explore how fast intuitive responses differ from slow deliberate reasoning, and why then adaptively switching between these styles can boost their effectiveness and user trust. So can you explain the differences between System 1 and System 2 thinking, particularly in the context of how large language models, LLMs, typically operate?
System 1 and System 2. Thinking can be understood just like two different ways of solving problems. Imagine you are just playing a video game. System 1 is like your instinctive reactions, quick and automatic, like dodging an obstacle without actually thinking too much. This type of thinking is fast and uses really simple rules, which can sometimes lead to confident but incorrect answers. On the other hand, System 2 is like carefully planning your strategy before making a move in the game. So this thinking is slower and more deliberate, allowing for deeper analysis, but taking more time and resources. In the context of large language models, LLMs, System 1 models tend to respond quickly and can be very effective at common sense reasoning, which is like understanding everyday situations. However, they might also make mistakes and be overly confident in their wrong answers. System 2 models, in contrast, are better at tasks that require step-by-step reasoning, such as solving math problems, but they can take longer to provide answers and might use more computer power. The goal of aligning LLMs with these two types of thinking is to find a balance. By adjusting how the models think, we can improve their performance in various situations, ensuring they provide accurate and reliable outputs without actually being misled by their own confidence.
What methods were used in the study to create the dataset of tasks, and how did the researchers ensure that the tasks provided valid System 1 and System 2? So, answers.
To create the dataset of tasks. So the researchers used cognitive heuristics, which are like mental shortcuts that help people make quick decisions. They identified 10 different cognitive heuristics to distinguish between System 1 and System 2 reasoning, so the dataset creation involved 4 stages. So though the specific details of those stages aren't provided, to ensure that the tasks provided valid answers for both reasoning types. So the researchers paired each question with 2 different types of answers. The System 1 answers were designed to be intuitive and quick, so reflecting the mental shortcuts associated with the question. In contrast, the System 2 answers were more deliberate and detailed, using reasoning to address or correct the initial quick response. Additionally, the researchers expanded their data set by combining expert-generated samples with just descriptions of how each system would respond. This process helped highlight the differences in response styles, like with System 2 answers being longer and more thorough, while System 1 answers were shorter and more straightforward. This careful design aimed to ensure that both types of answers were so valid and representative of their respective reasoning styles.
So what were the key findings regarding the performance of System 1 aligned versus System 2 aligned models, particularly in terms of their accuracy and the types of tasks they excelled in?
The key findings regarding the performance of System 1 aligned versus System 2 aligned models reveal a clear trade-off between accuracy and efficiency. So System 2 aligned models performed exceptionally well in tasks that require structured multi-step reasoning, such as arithmetic and symbolic reasoning. They consistently outperformed other models in these areas, showing that they're better at handling complex problems that need careful thinking. So, however, these models tended to generate longer and more detailed responses, which means they used more computational resources. On the other hand, System 1 aligned models excelled in common sense reasoning tasks, where quick intuitive judgments are essential. These models produce shorter and more direct responses, making them efficient in scenarios where heuristic shortcuts work so well. In fact, in tasks like the CSQA and strategy benchmarks, System 1 models outperformed their System 2 counterparts and other baseline models, demonstrating their strength in intuitive kind of reasoning. In summary, System 2 models are best for complex step-by-step problems, while System 1 models shine in everyday reasoning, highlighting the unique advantages of both reasoning styles in different contexts.
So how do the findings of this study challenge the traditional notion that step-by-step reasoning is universally optimal for all tasks? And so what implications does this have for the future design and application of LLMs?
The findings of this study challenge the traditional belief that step-by-step reasoning is always the best approach for every task. Instead, the research shows that both System 1 intuitive and System 2 deliberative reasoning have their own strengths depending on the nature of the task. For example, while structured reasoning is great for complex problems, intuitive reasoning can be more effective for everyday situations that require really quick judgments. This insight suggests that future designs of large language models, the LLMs, should not just focus on improving step by step, like reasoning. Instead, LLMs could benefit from being flexible, allowing them to switch between intuitive and deliberative thinking just based on what the task requires. So this adaptability could lead to more efficient and effective models that perform better in real-world applications, such as conversational agents or automated decision-making systems. By grounding the findings in cognitive science, the study really emphasizes the importance of choosing the right reasoning strategy for specific tasks. This approach aligns LLM reasoning more closely with how humans think, so paving the way for advancements and creating models that are not only smarter but also more aligned with human-like cognition. This could lead to better performance in a wider range of applications, making LLMs more robust and versatile. So
in light of this study's findings, what are some potential future research directions or applications that could further explore or implement the idea of flexible reasoning strategies in LLMs?
So based on the findings of this study, several potential future research directions and applications could further explore or implement flexible reasoning strategies in large language models, LLMs. So one direction is to develop and refine adaptive reasoning frameworks that allow LLMs to dynamically switch between System 1 and System 2, so thinking based on the specific demands of a task. This could involve creating experimental setups that systematically test when each reasoning style is most effective, helping to identify the best approach for different kinds of scenarios. And another area of research could really focus on improving prompt engineering technique by designing prompts that effectively guide LLMs toward either intuitive or deliberate reasoning. So researchers can enhance the model's ability to align their responses with the needs of the task at hand. This could lead to better performance in various applications, such as chatbots that need to respond quickly and accurately, or systems that require really careful analysis and decision-making. Additionally, exploring the implications of this flexible reasoning approach in real-world applications could be valuable. So, for instance, researchers could investigate how adaptive reasoning strategies can improve the efficiency and accuracy of conversational agents or automated decision-making systems, making them more effective in practical scenarios. Finally, further research could really aim to integrate insights from cognitive science into LLM design, ensuring that these models not only achieve high benchmark scores, but also reflect the structured and adaptable nature of human reasoning. So maybe this could pave the way for more robust and versatile reasoning systems that can handle a wider range of tasks effectively.
So how might the implementation of flexible reasoning strategies in LLMs impact user interaction and trust in AI systems, particularly in applications like customer service or educational tools?
The implementation of flexible reasoning strategies in LLMs could actually significantly impact user interaction and trust in AI systems, especially in applications like customer service or educational tools. By allowing models to dynamically switch between fast, intuitive responses, System 1, and more careful, detailed answers, System 2, users might experience more natural and effective interactions. For instance, in customer service, a model that can quickly provide pretty straightforward answers to common questions can enhance user satisfaction by making the interaction feel efficient and responsive. On the other hand, when faced with more complex inquiries, the model can actually take its time to provide thorough explanations, which can actually build trust by demonstrating a deep understanding of the issue. However, there are really important trade-offs to consider. System 1 models may sometimes give overly confident but incorrect answers, which could actually lead to frustration or mistrust if users feel misled. Conversely, System 2 models might slow down response times, which could actually frustrate users looking for quick help. Balancing these trade-offs is so crucial to ensure that users have a positive experience and feel confident in the reliability of the AI system. Training LLMs to align their reasoning strategies with the needs of specific tasks can actually help address these concerns by grounding the models in cognitive science and ensuring they can adapt their reasoning style, so developers can create systems that not only provide accurate information, but also align with user expectations for speed and reliability. So this adaptability could foster greater trust in AI systems as users see them responding appropriately to different contexts and needs.
So thank you for joining us for another insightful discussion. Tonight, we delve deep into the fascinating world of large language models and their approach to thinking, just drawing parallels with our own cognitive processes. Our discussion with our esteemed guest truly illuminated the critical distinctions between System 1 and System 2, so thinking in LLMs. We just learned how System 1 thinking enables those rapid instinctive and intuitive responses, excelling in common sense reasoning, though sometimes at the risk of overconfidence. And also, System 2 thinking, while more deliberate, resource-intensive, and slower, is crucial for tackling complex step-by-step reasoning tasks. The insights shared across truly underscore that no single approach is universally superior. Instead, the real power lies in the potential for LLMs to intelligently adapt, so seamlessly shifting between these reasoning styles depending on the specific demands of a task. So this adaptive flexibility promises not only to enhance their overall effectiveness, but also to build greater user trust, especially in critical applications like customer service and education. It opens really exciting avenues for future research into developing these adaptive frameworks and refining prompt engineering for optimal performance across diverse tasks. So, thank you again for tuning in. We just look forward to exploring more cutting-edge topics with you next time. Good night.